Sound recording and reproduction is an electrical or mechanical inscription and recreation of sound waves, such as spoken voice, singing, instrumental music, or sound effects. The two main classes of sound recording technology are analog recording and digital recording. Acoustic analog recording is achieved by a small microphone diaphragm that can detect changes in atmospheric pressure and record them as a graphic representation of the sound waves on a medium such as a phonograph. In magnetic tape recording, the sound waves vibrate the microphone diaphragm and are converted into a varying electric current, which is then converted to a varying magnetic field by an electromagnet, which makes a representation of the sound as magnetized areas on a plastic tape with a magnetic coating on it. Analog sound reproduction is the reverse process, with a bigger loudspeaker diaphragm causing changes to atmospheric pressure to form acoustic sound waves. Electronically generated sound waves may also be recorded directly from devices such as an electric guitar pickup or a synthesizer, without the use of acoustics in the recording process other than the need for musicians to hear how well they are playing during recording sessions. Digital recording and reproduction converts the analog sound signal picked up by the microphone to a digital form by the process of digitization. This lets the audio data be stored and transmitted by a wider variety of media. Digital recording stores audio as a series of binary numbers representing samples of the amplitude of the audio signal at equal time intervals, at a sample rate high enough to convey all sounds capable of being heard. Digital recordings are considered higher quality than analog recordings, not necessarily because they have higher fidelity, but because the digital format can prevent much loss of quality found in analog recording due to noise and electromagnetic interference in playback, and mechanical deterioration or damage to the storage medium. A digital audio signal must be reconverted to analog form during playback before it is applied to a loudspeaker or earphones. Prehistory. Long before sound was first recorded, music was recorded, first by written notation, then also by mechanical devices. Automatic music reproduction traces back as far as the 9th century, when the Banu Musa brothers invented the earliest known mechanical musical instrument, in this case a hydro-powered organ that played interchangeable cylinders. According to Charles B. Fowler, this cylinder with raised pins on the surface remained the basic device to produce and reproduce music mechanically until the second half of the 19th century. The Banu Musa brothers also invented an automatic flute player, which appears to have been the first programmable machine. According to Fowler, the automata were a robot band that performed more than 50 facial and body actions during each musical selection. In the 14th century, Flanders introduced a mechanical bell ringer controlled by a rotating cylinder. Similar designs appeared in barrel organs, musical clocks, barrel pianos, and musical boxes. The fairground organ, developed in 1892, used a system of accordion-folded punched cardboard books. The player piano, first demonstrated in 1876, used a punched paper scroll that could store an arbitrarily long piece of music. The most sophisticated of the piano rolls were hand-played, meaning that the roll represented the actual performance of an individual, not just a transcription of the sheet music. This technology to record a live performance onto a piano roll was not developed until 1904. Piano rolls have been in continuous mass production since around 1898. A 1908 U.S. Supreme Court copyright case noted that, in 1902 alone, there were between 70,000 and 75,000 player pianos manufactured, and between 1 million and 1,500,000 piano rolls produced. The use of piano rolls began to decline in the 1920s, although one type is still being made today. Phonograph. The first device that could record actual sounds as they passed through the air was the phonograph. patented in 1857 by Parisian inventor Edouard Lecouteux and Scott de Martinville. The earliest known recordings of the human voice are phonautograph recordings, called phonograms, made in 1857. They consist of sheets of paper with sound wave modulated white lines created by a vibrating stylus that cut through a coating of soot as the paper was passed under it. An 1860 phonogram of Au clair de la lune, a French folk song, was played back as sound for the first time in 2008 by scanning it and using software to convert the undulating line, which graphically encoded the sound, into a corresponding digital audio file. Phonograph. Phonograph cylinder. On April 30, 1877, French poet, humorous writer and inventor Charles Cros submitted a sealed envelope containing a letter to the Academy of Sciences in Paris fully explaining his proposed method, called the palleophone. Though no trace of a working palleophone was ever found, Cros is remembered as the earliest inventor of a sound recording and reproduction machine. The first practical sound recording and reproduction device was the mechanical phonograph cylinder, invented by Thomas Edison in 1877 and patented in 1878. The invention soon spread across the globe, and over the next 2 decades the commercial recording, distribution and sale of sound recordings became a growing new international industry, with the most popular titles selling millions of units by the early 1900s. The development of mass production techniques enabled cylinder recordings to become a major new consumer item in industrial countries, and the cylinder was the main consumer format from the late 1880s until around 1910. Disc phonograph. The next major technical development was the invention of the gramophone disc, generally credited to Emil Berliner and commercially introduced in the United States in 1889. Though others had demonstrated similar disc apparatus earlier, most notably Alexander Graham Bell in 1881. Discs were easier to manufacture, transport and store, and they had the additional benefit of being louder than cylinders, which by necessity were single-sided. Sales of the gramophone record overtook the cylinder. California, 1910, and by the end of World War I the disc had become the dominant commercial recording format. Edison, who was the main producer of cylinders, created the Edison disc record in an attempt to regain his market. In various permutations, the audio disc format became the primary medium for consumer sound recordings until the end of the 20th century, and the double-sided 78 revolutions per minute shellac disc was the standard consumer music format from the early 1910s to the late 1950s. Although there was no universally accepted speed, and various companies offered discs that played at several different speeds, the major recording companies eventually settled on a de facto industry standard of nominally 78 revolutions per minute. Though the actual speed differed between America and the rest of the world, the specified speed was 78.26 revolutions per minute in America and 77.92 revolutions per minute throughout the rest of the world. The difference in speeds was a result of the difference in cycle frequencies of the AC power driving the stroboscopes used to calibrate recording lathes and turntables. The nominal speed of the disc format gave rise to its common nickname, the 78. Discs were made of shellac or similar brittle plastic-like materials, played with needles made from a variety of materials including mild steel, thorn and even sapphire. Discs had a distinctly limited playing life that varied depending on how they were produced. Earlier, purely acoustic methods of recording had limited sensitivity and frequency range. Mid-frequency range notes could be recorded, but very low and very high frequencies could not. Instruments such as the violin were difficult to transfer to disc. The horn was no longer required once electrical recording was developed. The long-playing 331/3 of a revolution per minute microgroove vinyl record, or LP, was developed at Columbia Records and introduced in 1948. The short playing but convenient 7-inch 45 revolutions per minute microgroove vinyl single was introduced by RCA Victor in 1949. In the US and most developed countries, the two new vinyl formats completely replaced 78 revolutions per minute shellac discs by the end of the 1950s. But in some corners of the world, the 78 lingered on far into the 1960s. Vinyl was much more expensive than shellac, one of several factors that made its use for 78 revolutions per minute records very unusual. But with a long playing disc, the added cost was acceptable, and the compact 45 format required very little material. Vinyl offered improved performance, both in stamping and in playback. If played with a good diamond stylus mounted in a lightweight pickup on a well-adjusted tone arm, it was long-lasting. If protected from dust, scuffs and scratches, there was very little noise. Vinyl records were, over-optimistically, advertised as unbreakable. They were not, but they were much less fragile than shellac, which had itself once been touted as unbreakable, compared to wax cylinders. Electrical recording. Between the invention of the phonograph in 1877 and the advent of digital media, arguably the most important milestone in the history of sound recording was the introduction of what was then called electrical recording, in which a microphone was used to convert the sound into an electrical signal that was amplified and used to actuate the recording stylus. This innovation eliminated the horn sound resonances characteristic of the acoustical process, produced clearer and more full-bodied recordings by greatly extending the useful range of audio frequencies, and allowed previously unrecordable distant and feeble sounds to be captured. Sound recording began as a purely mechanical process. Except for a few crude telephone-based recording devices with no means of amplification, such as the telegraphone, it remained so until the 1920s. When several recent radio-related developments in electronics converged to revolutionize the recording process. These included improved microphones and auxiliary devices such as electronic filters, all dependent on electronic amplification to be of practical use in recording. In 1906, Lee de Forest invented the audio triode vacuum tube, an electronic valve that could amplify weak electrical signals. By 1915, it was in use in long-distance telephone circuits that made conversations between New York and San Francisco practical. Refined versions of this tube were the basis of all electronic sound systems until the commercial introduction of the first transistor-based audio devices in the 1950s. During World War I, engineers in the United States and Great Britain worked on ways to record and reproduce, among other things, the sound of a German U-boat for training purposes. Acoustical recording methods of the time could not reproduce the sounds accurately. The earliest results were not promising. The first electrical recording issued to the public with little fanfare was of November 11, 1920 funeral services for the unknown soldier in Westminster Abbey, London. The recording engineers used microphones like those in contemporary telephones, discreetly set up in the Abbey and wired to recording equipment in a vehicle outside. Although they used electronic amplification, the audio was weak and unclear. The procedure did, however, produce a recording that would otherwise not have been possible in those circumstances. For several years, this little-noted disc remained the only issued electrical recording. Several record companies and independent inventors, notably Orlando Marsh, experimented with equipment and techniques for electrical recording in the early 1920s. Marsh's electrically recorded autograph records were already being sold to the public in 1924, a year before the first such offerings from the major record companies. But their overall sound quality was too low to demonstrate any obvious advantage over traditional acoustical methods. Marsh's microphone technique was idiosyncratic and his work had little if any impact on the systems being developed by others. Telephone industry giant Western Electric had research laboratories with material and human resources that no record company or independent inventor could match. They had the best microphone, a condenser type developed there in 1916 and greatly improved in 1922, and the best amplifiers and test equipment. They had already patented an electromagnetic recorder in 1918, and in the early 1920s they decided to intensively apply their hardware and expertise to developing two state-of-the-art systems for electronically recording and reproducing sound, one that employed conventional discs and another that recorded optically on motion picture film. Their engineers pioneered the use of mechanical analogues of electrical circuits and developed a superior, rubber-line recorder for cutting the groove into the wax master in the disc recording system. By 1924 such dramatic progress had been made that Western Electric arranged a demonstration for the two leading record companies, the Victor Talking Machine Company and the Columbia Phonograph Company. Both soon licensed the system and both made their earliest published electrical recordings in February 1925, but neither actually released him until several months later, to avoid making their existing catalogues instantly obsolete. The two longtime arch-rivals agreed privately not to publicize the new process until November 1925, by which time enough electrically recorded repertory would be available to meet the anticipated demand. During the next few years the lesser record companies licensed or developed other electrical recording systems. By 1929 only the budget label Harmony was still issuing new recordings made by the old acoustical process. Comparison of some surviving Western Electric test recordings with early commercial releases indicates that the record companies dumbed down the frequency range of the system so the recordings would not overwhelm non-electronic playback equipment, which reproduced very low frequencies as an unpleasant rattle and rapidly wore out discs with strongly recorded high frequencies. Other recording formats. In the 1920s, phono film and other early motion picture sound systems employed optical recording technology, in which the audio signal was graphically recorded on photographic film. The amplitude variations comprising the signal were used to modulate a light source which was imaged onto the moving film through a narrow slit, allowing the signal to be photographed as variations in the density or width of a soundtrack. The projector used a steady light and a photoelectric cell to convert these variations back into an electrical signal, which was amplified and sent to loudspeakers behind the screen. Ironically, the introduction of talkies was spearheaded by the jazz singer, which used the Vitaphone sound on disc system rather than an optical soundtrack. Optical sound became the standard motion picture audio system throughout the world and remains so for theatrical release prints despite attempts in the 1950s to substitute magnetic soundtracks. Currently, all release prints on 35mm film include an analog optical soundtrack, usually stereo with Dolby Senior noise reduction. In addition, an optically recorded digital soundtrack in Dolby Digital or Sony SDDS form is likely to be present. An optically recorded timecode is also commonly included to synchronize CD-ROMs that contain a DTS soundtrack. This period also saw several other historic developments including the introduction of the first practical magnetic sound recording system, the magnetic wire recorder, which was based on the work of Danish inventor Valdemar Poulsen. Magnetic wire recorders were effective but the sound quality was poor, so between the wars they were primarily used for voice recording and marketed as business dictating machines. In 1924 a German engineer, Dr. Kurt Stiller, developed the Poulsen wire recorder as a dictating machine. The following year, Ludwig Blattner began work that eventually produced the Blattner phone, enhancing it to use steel tape instead of wire. The BBC started using Blattner phones in 1930 to record radio programs. In 1933 radio pioneer Guglielmo Marconi's company purchased the rights to the Blattner phone. and newly developed Marconi Stiller recorders were installed in the BBC's Maida Vale studios in March 1935. The tape used in Blatnophones and Marconi Stiller recorders was the same material used to make razor blades. And not as surprisingly, the fearsome Marconi Stiller recorders were considered so dangerous that technicians had to operate them from another room for safety. Because of the high recording speeds required, they used enormous reels about 1 meter in diameter, and the thin tape frequently broke, sending jagged lengths of razor steel flying around the studio. The K1 magnetophone was the first practical tape recorder, developed by AEG in Germany in 1935.